Question 1, we're given the points P and R, and they're two vertices of a square PQRS, where PR is a diagonal. We're asked to find the slope of PR. So we're going to use our slope formula, y2 minus y1 over x2 minus x1. I'm going to use my 2, 1 as my x1, y1, and my 5 minus 4 as my x2, y2. Filling into that formula, then we get minus 4 minus 1 over 5 minus 2, which simplifies to minus 5 over 3. And that's 5 marks. Question 2b then asks us to find the equation of the other diagonal QS. So if we have an other diagonal, what we understand is that that diagonal will go through the midpoint. They will bisect each other. So it will go through the midpoint of PR. So the first thing we're going to do here is to find that midpoint of PR. And using our midpoint formula, so that's x1 plus x2 over 2. So we're looking at 2 plus 5 over 2. And then all the y's, so y1 plus y2 over 2. So 1 minus 4 over 2. And that will simplify to 7 over 2 minus 3 over 2. So that's my midpoint. In order to get the equation of a diagonal, we need a point on the line, so that's what we have there. And we also need the slope. Now we know that the slope of the other diagonal is minus 5 over 3. This line, QS, will be perpendicular to the other diagonal because this is a diagonal of a square. So because of that, the slope of QS must be then equal to the negative reciprocal. So basically flipping this fraction over and changing the sign. So it becomes a positive 3 over 5 as a slope for QS. So using these two pieces of information, we're going to fill into my y minus y1 equals m times x minus x1 formula for the equation of a line, where my x1 and y1 in this case are my midpoint, and then my slope is my m of 3 over 5. So that's going to look like y minus 3 over 2 is equal to 3 over 5 times x minus 7 over 2. Double negative will become a positive there. Multiplying this out, 3 over 5x minus 21 over 10. We don't want the fractions there, so to eliminate the fractions, highest denominator here is 10. So if I multiply across by 10, that will eliminate the fractions. So we end up with 10y plus 15 is equal to 6x minus 21. And then we try and just tidy that up a little bit. So we could bring all the numbers to one side and x's and y's to the other if I keep the x's positive. So the 15 add on the 21, we get 36 is equal to 6x minus 10y. We can divide across by 2 if we wanted to as well, so we would end up with 18 equals 3x minus 5y, or 3x minus 5y equals 18, whichever way you want to say it. And that is a 10-mark question. Part C asks us to write down the measure of the acute angle PQS and hence find the slope PQ and the equation of PQ. Okay, so looking first of all at the angle, we have an acute angle PQS. So PQS, if I just quickly just do a little sketch line across there, that's the angle that they're talking about here. What we have, or what we understand that we have, is a square. So that means that this side here and this side here are equal to each other. So PQ and PS are equal in length. Just looking at that triangle there, we have an isosceles triangle. We also know that this is a right angle because it is a square. So if this is 90 degrees, the other two angles, one of which is the angle that we're talking about here, are equal to each other because it's an isosceles triangle. We also know that they have add up to give me 90 degrees. Each of them have to be equal, so therefore the angle PQS must be equal to 45 degrees. So that's the first step in this equation. They're then asking us to find the slope, hence find the slope. So using that piece of information, find the slope of PQ. So again, PQ we're talking about is this line here. We previously found the slope of QS. Okay, this line here, and we know that the slope of QS was equal to 3/5. Now, the reason why that's important is because we have a formula in our log tables book, and that formula is on page 19 of our log tables book, and it's this one here, where we have angles between two lines of slopes M1 and M2. So when we have the slope of two lines and we have the angle in between, we can use this formula here. Well, we know that the angle in between here is 45. We know that the slope of QS, we are looking for the slope of PQ. And this formula will help us to do that. So I'm going to have my 3/5 as my M1. I don't have a M2, so I'm not going to fill in anything other than M2 for that into the formula. And my angle is 45 degrees. So filling into that formula, tan of 45 degrees is equal to plus or minus, okay, my M1, which is 3/5, minus M2, all over 1 plus 3/5, 3/5, times M2. Now, the tan of 45 is 1. So 1 equals plus or minus 3/5. If you wanted to, you could do a little square bracket around that. So 3/5 minus M2 over 1 plus 3/5 times M2. We obviously have the plus minus, so we need to make sure we keep that there. But what we can do is we can sort of eliminate this fraction by bringing up the denominator. We're still going to keep the plus minus with the numerator on the right hand side. So that's not going to make any difference there. We just want to eliminate the fraction to be able to try and solve for M2 here. So if I multiply it on the other side, it's multiplying by 1, so it's just going to be itself on the other side. So 1 plus 3/5 M2 is equal to plus or minus 3/5 minus M2. Suppose I'm protecting this with the bracket because of that plus minus on the outside. I could also then multiply both sides by 5, again to eliminate the 3/5 would be helpful, and would just make it look a little bit nicer. So multiplying by 5 on both sides, I would get 5 plus 3 M2 is equal to plus or minus 3 minus 5 M2. And this is where I'm now going to split up into the plus and the minus. So if I take the plus first, 5 plus 3M2 is equal to 3 minus 5M2. Bringing my M2's together, I would get 8M2 is equal to 3 minus 5, which is minus 2. M2 then will be equal to minus 1/4. If I look at the negative, we have 5 plus 3M2 is equal to minus 3 and a plus 5M2. So that's important that we multiply that minus into the bracket correctly. So negative 3 and a positive 5M2. Bringing our M2's together and bringing our numbers to the other side, we would end up with 8 equals 2M2. So M2 in this case is equal to 4. So then we need to look at what we have. If we go back to our diagram, which of these slopes makes sense? Which one is relating to the diagram that we have and the QS that we have? So if we look at QS, sorry, not QS, I mean PQ. If we look at PQ, it's a positive line, okay? It would have a positive slope looking at it, and therefore the answer that we're going to take here for my slope is that M2 is equal to 4. Why? Because it is positive. Now, once I have the slope of PQ, they're asking me to find the equation of PQ. So I have the slope. Do I have a point? Yes, I do. I have the point 2, 1 from the diagram. So I'm going to fill into y minus y1 equals m times x minus x1 again. So that's y minus 1 is equal to 4 times x minus 2. And when I do any simplifying with that, I get y minus 1 is equal to 4x minus 8. A little bit of rearranging, we could get an equation of y equals 4x minus 7. Doesn't state what way to leave the equation, so as long as I've simplified it as much as I can, that is absolutely fine. And that question was 10. Part D asks us to find the coordinates of Q and S. So if I go back up to my diagram here, Q is here. It's the point where the line PQ and QS would meet, and S obviously the other vertex over here. We're going to focus on Q first. It is where two lines meet that we already have the equation of. So we have just found the equation of PQ, and we previously found the equation of QS in part B. So because we have the two equations, we can use our simultaneous equations to find the point where they intersect. So we have the equation of 3x minus 5y equals 18. I'm going to rearrange the previous way that I left this and bring the x's and the y's on the same side. So what I would say here is 4x minus y is equal to 7. This is a slight rearrangement of the previous answer that we just got. And I'm going to solve for x and y here. I'm going to multiply the bottom equation by minus 5 so I can eliminate the y's. You have other options there if you wanted to, but I think that's the easiest way to do it. So top equation stays the same. If I multiply that bottom equation, I get minus 20x. I get a plus 5y and a minus 35. Okay, the y's will obviously eliminate. We end up with minus 17x is equal to minus 17. So x is equal to 1. It's my first part of the solution. And when x is equal to 1, I fill that back in to find out my y value. So I end up with 3 minus 5y equals 18. So minus 5y is equal to 15. 5y then is equal to minus 15, so y is equal to minus 3. So the point Q is the point 1 minus 3. Now, to find out what S is, we'll back up to our diagram here. So there's our point Q, and that was the point 1 minus 3 that we've just found. Now, to get S, we're going to use a translation, because we know this point here. The midpoint here where those two diagonals meet is the point 7 over 2 minus 3 over 2 we found previously in a different part of the question. So I know if I can look at moving this point to the midpoint, if I move it on by the exact same amount, I should end up at the opposite vertex, which is S. So let's see what that looks like. So I have the point Q, which is 1 minus 3. And if I translate that to the midpoint, 7 over 2 minus 3 over 2, what do I do to each part of the point? So the x value, first of all, I am adding 2.5, 2.5 to the x value. So if I add 2.5 to 1, I get 7 over 2. Again, maybe it might be easier if I wrote that as 3 over 3.5, but that's exactly what I'm going to be doing regardless. And if I look at the y value, of the point Q, if I were to translate it to the midpoint here, that would be the same as adding 1.5 to the y value. So as long as I do the exact same thing to the x value of the midpoint and the y value of the midpoint, I should end up at the point S over here on the other side. So with the x value, I'm going to add 2.5. And when I add 2.5 to 7 over 2, or 3.5, I end up with 6. And with the y value, I'm going to add 1.5 I have a minus 3 over 2 or minus 1.5, so that actually ends up at 0. So my point S is the point 6, 0. That question in total was 5 marks. Question 2, part 1 tells us that a box contains identical discs that are numbered as follows. 6 are numbered 10, 4 discs are numbered 5, and 2 discs are numbered 3. So 5 discs are drawn without replacement from the box. We're asked to find the probability that all 5 discs drawn are numbered 10. So the first thing we need to look at is how many discs there are in total. If we add the 6, the 4, and the 2, we have 12. So if they are all number 10, the probability of the first one being number 10 is 6 out of 12. Multiplied by the second one, which would be 5 out of 11. Multiplied by 4 over 10. Multiplied by 3 over 9. And finally, that the fifth one is also number 10 would be 2 over 8. And when we do that calculation, we get a probability of 1 over 132. And that question is worth 5 marks. For part 2, we're asked to find out the probability that at least 2 discs are number 10. So we're looking at that being the probability that 2 discs are number 10, the probability of 3 also being number 10, added to the probability of 4 discs, and also getting the probability or having the probability of 5 discs being numbered 10. I suppose an easier way, instead of going through all these probabilities, an easier way might be to say, well, what's the probability of it not being so less than 2 discs being numbered 10, and taking that away from 1, because all probabilities add up to 1. So looking at calculating 1 minus the probability of 0 discs being numbered 10 and the probability of 1 disc being number 10. So there's a little bit less work with that. So we would have 1 minus the probability of 0, none of the discs being numbered 10. We would have 6 discs that are not number 10, multiplied by 5 over 11, multiplied by 4 over 10, multiplied by 3 over 9, and then 2 over 8. Plus the probability of 1 disc. Well, there's 6 out of 12 chances that a disc would be number 10. The next probability will be 6 over 11. The 6 being all of the discs that don't have the 10 on them out of 11 that are left. And we carry on from there. So 5 over 10, 4 over 9, and 3 over 8. Now, the thing about that is there are many different ways that that can happen. I have just written down here the first disc being number 10, but we could have it that the second one that's pulled is number 10, or the third, or the fourth, or the fifth. So there's actually 5 different ways. So we actually have to multiply whatever this probability here is by 5, because there are 5 different ways that that event can happen. So what are we left with? We're left with 1 minus 1 over 132 plus 5 times 1 over 44 when I calculate that second probability. That leaves me with 1 minus 4 over 33, which is 29 over 33. And that answer, that question, is worth 5 marks. Part 3 asks us to find the probability that the sum of the numbers on the 5 discs is greater than 40. And really there's only 2 ways, well, there's only a certain amount of ways that that can happen, I should say. So probability of the sum being greater than 40. Well, one of the ways is the probability that the 5 discs that are picked are numbered 10. So we've already calculated that probability. But also, we have the probability that 4 of the discs are numbered 10, giving us 40, obviously, and 1 disc is numbered either 3 or 5. Okay? So, looking at that probability, the probability that the sum is greater than 40 would be the probability that 5 discs are numbered 10, which is 1 over 132, plus, now how many ways can this happen? Well, we could have the first 4, for example. We might have 6 over 12, probability of getting a 10, followed by another 10, followed by another 10, and followed by another 10. Okay, and then the probability that the last one, the last disc that is drawn is either a 3 or a 5, is going to be a chance 6 out of 8 possible. Okay, but that's just one way that can happen, one order in which it can happen. There are 5 different orders in which that can happen. So we need to make sure that that's got into the calculation. So when I'm working that out, I end up with 5 over 1 over 44, and my answer is 4 over 33 when I bring that together. And again, that's worth 5x. Question 2b. We have 5 college students arrive at a lecture. The only seats remaining in the lecture hall are at the front, where there are 9 vacant seats together in a row. How much more likely is it that all 5 students are seated together than no 2 of them are seated beside each other? And use probabilities to justify your answer. So this question is worth 15 marks. The first thing that we would have to know is how many, or the total number of ways that 5 students can be seated in these 9 seats, okay? So the total number of ways that they can be seated in 9 seats, I can work out by using 9p5 or 9 factorial over 9 minus 5 factorial. And when I work that out, I calculate that there are 15,120 different ways that these 5 students could be seated in the 9 seats that are vacant. Looking first of all at them seated together. So if they're all seated together, there's a few different ways that can happen. So they could be in seats 1 to 5, or they could be in seats 2 to 6, 3 to 7, 4 to 8, or finally 5 to 9. Okay, so there are 5 different ways that they can be seated together in these 9 seats. So 5 times 5 factorial means that there are 600 ways that they could be seated together. So the probability of all seated together will be 600 out of the total number of possible ways, 15,120. Simplifying to 5 over 126. Now, the next thing we need to look at is if they are not sat together. Okay, so no student sat together. Really, there's only one way that can happen. So if we have a student in seat 1, in seat 3, in seat 5, 7, and 9. So a seat empty in between each of the students. So how many ways can that happen? It's going to be 5 factorial ways. So that's 120 ways that they can be, that no student can be sat, and no 2 of them are sat beside each other. So the probability of no two students sat together is 120 out of 15,120, which simplifies to 1 over 126. So, going back to my question, how much more likely is it that all 5 students are seated together than that no two of them are seated beside each other? So looking at my probability that they are all seated together is 5 over 126. My probability that no two students are sat together is 1 over 126. So we would conclude that the probability of 5 students sat together is 5 times more likely to happen than no two of them sat together. And hopefully we can see that clearly from the probabilities that we have there. That question, like I said, is worth 15 marks. Question 3a. So we have a circle question here where we're given the equation of a circle and we're asked to find the centre and the radius of the circle, giving our answer for the radius in third form. So looking first of all as to how this equation is given to us, the first thing that we would have to do is expand the brackets that we have here. So when I expand those, I end up with x squared minus 6x plus 2x minus 12 plus y squared minus 2y plus 8y minus 16 equals 0. And then making it look a little bit more like the equation of a circle that we would be used to. So I have our x squared value first, plus our y squared. Then our x's, so we're looking at a minus 6x and a plus 2x, so that's going to give me a minus 4x. My y's, I've got a minus 2y and a plus 8y, so that's a plus 6y. And then we have our numbers. So we've minus 12, minus 16 gives me a minus 28 equal to 0. So that's a little bit more familiar to us than what we're used to. Now, if we look in our log tables book on page 19, we know that we have an equation of a circle here, a general equation of a circle. And if I compare that to what I have, my 2g in this case is equal to minus 4. And 2f, which is the coefficient of y, in this case is 6. So 2f is equal to 6. And that's important because this is the equation of a circle when the centre is minus g minus f. So if I know here that g is equal to minus 2 and f is equal to 6, f is equal to 6 divided by 2, which is 3, then I know that my centre will be changing the sign positive 2 and changing the sign negative 3. So that's my center point. I then know also that the radius, I can use this formula here. So when I'm looking for r, the radius, I'm doing g squared, which is minus 2 squared, plus f squared, which is 3 squared, minus c. And c in this case is my number here on the end. Be careful, it's already a negative, so it's minus 28. It is important that we make sure we have the negative with the 28 as well. So r then will be equal to 4 plus 9 and then plus 28 because of the double negative. So r is equal to the square root of 41. And that's my answer for the radius. And that in total is worth 10 marks. A part 2, the equation of the line t is 5x plus 4y plus k equals 0. and t is a tangent to the circle S. So we're still talking about the same circle from the previous part. It might be worth doing a little bit of a quick sketch here. So this is our circle S. We know that now that the center of S is 2 minus 3, and we know that the radius is root 41. Now, if this is a tangent to the circle, it touches the circle at one point. I can tell by looking at that equation, if I was to rearrange that into the y on one side, I'd end up with a minus 5x minus k. So we're looking at it having a negative slope, just for the purpose of the diagram. So I know that the line is going to look something like that, maybe negative here, but there's also the potential that it could be on the other side as well and touch the circle here. Okay, so that's why we're going to get two possible values of k. There are two possible places that this line could be in. So when I draw my diagram, my quick sketch here, I know that that measurement there is root 41. I also know that the measurement here is root 41. So that's just putting in the information that I know on the diagram. I also know, and just remember, that a tangent meets a radius at a right angle. Okay, so they are perpendicular to each other. How is that useful? Well, we do have a formula in our log tables book on page 19 on the distance from a point to a line. Okay, so a point, in this case, we're going to use a center point, and the line being the equation of the line that we have here for t that's given to us. So we're going to use that formula. Okay, so my ax1 plus by1 plus c is the absolute value over square root of a squared plus b squared. So what's my x1? My x1 will be 2. My y1 will be minus 3. My a will be 5. Again, it's the x coefficient that's here. My b will be 4, so my y coefficient, and my c is 3. So, and I know what the distance, the perpendicular distance is here from the point to the line. So I can say that root 41 is equal to 5 times 2 plus 4 times minus 3 plus k. The absolute value of that all over square root of 5 squared plus 4 squared. So that's filling into my formula. And I work that out. Okay, I do whatever I can here to simplify it. So square root of 41 will be equal to the absolute value of 10 minus 12 plus k on the top over the square root of 25 plus 16. So root 41 is equal to the absolute value of minus 2 plus k over the square root of 41. If I bring up that denominator and multiply both sides by root 41, I'm going to end up with 41 equals the absolute value of minus 2 plus k. Once I reach to this point, then I'm looking at how do I work with this absolute value. Well, I know that the minus 2 plus k could be positive or it could be negative. So, dealing with that, it could be 41 is equal to minus 2 plus k, so a positive answer. Or we might have a negative answer, so minus 41 is equal to minus 2 plus k. Solving each one, 43 is equal to k, and minus 39 is equal to k. And those are my two values for k. And that question was worth 5 points. Part B gives us C1 and C2 are two circles touching externally at the point P. C1 has a center of O1 and touches the y-axis at the point 0, 17. So that piece of information is not on the diagram. So we're looking at a point being there, and we know that that is 17 on the y-axis. Okay, so it's 17 distance up here. It then tells me that C2 has a center of O2 and touches the x-axis at the point 19, 0. So again, down here, we're looking at that being 19 on the x-axis. The length of the radius of C1 is twice the length of the radius of C2. We have no measurements for that. So anything that we don't know, what we can do is we can give it a letter. The easiest one for the radius is to give it r. So looking at that, I can label that one r. I can also join the radius to the point P and then on to the point or the center O1. This is a measurement of r. If I know that this radius is twice that, I can call it 2r. And again, I can also draw another line here, which should go to the point 17. And we can call that 2r as well. So we're just filling in some of that extra information that's given to us in the wording of the question, but not actually on the diagram. So the question, part 1, is asking me to find the equation of C1 and the equation of C2. In order to get the equation of a circle, we need a center and we need a radius. So the first thing we're going to look at is center. So the center of C1, well, I can use some of the information that I've got here. Yes, it'll be in terms of r, but that's what I have. So if I know that this is the point 17 up here, okay, or this is 17 on the y-axis, drawing my line straight across, then the y value of my center point should be 17. And equally, if I know this measurement here is 2r, then on my x-axis, that's what it's in line with. Yes, we don't know what r is, but we're going to keep it in terms of r. So we can represent the center of C1 as 2r 17. In the exact same way, I can look at the center of C2, and I can say on the x-axis, it will have an x value of 19, and it will have a y value of r. So that's using the center points in terms of r. So I need to be able to solve for r to be able to find these center points. So I'm going to use another piece of information that I have here. I know that the distance between these two centers is equal to 2r and the r, the two radius combined. So using my distance formula and the points that I have that are here in terms of r, I'm going to fill into that distance formula. And I know what the answer is. I know the answer is going to be 3r. So 3r will be equal to the square root of 19 minus 2r to be squared plus r minus 17 to be squared. So again, filling in my coordinates for the centers, we're finding the distance between those 2 points, and I know that can be represented as 3r. So working out, well, if I square both sides to just eliminate the square root, I'll end up with 9r squared is equal to 19 minus 2r to be squared plus r minus 17 to be squared. And the next thing that we can do here is square out those two brackets. So 9r squared will be equal to 361 minus 76r plus 4r squared plus r squared minus 34r plus 289. When we want to solve for r, what we're going to have to do here is get a quadratic equal to 0 and solve that. So getting everything to the one side equal to 0 is priority. So we have 9r squared. We have a plus 4r squared and a plus r squared over here. So that's going to become that's plus 5r squared. Bring it over to the other side. We're looking at that simplifying to 4r squared. We have a minus 76r and a minus 34r. Altogether, that's 110. It's going to be a positive 110 when we bring it together on the left-hand side. And then we have 361 and 289, which adds to give me 650. It'll be a minus 650 when we bring it to the left-hand side. And that's equal to 0. I can make my life a little bit easier for myself and maybe divide by 2 here. So 2r squared plus 55r minus 325 equals 0. And you can use your minus b formula if you wanted to, or you can factorize and solve. It's really up to you, personal preference. If I was to factorize, I should get brackets of 2r plus 65 and r minus 5 in brackets. And when I solve that, 2r plus 65 equals 0. So 2r is equal to minus 65. R will be equal to minus 32.5. And on this side, r minus 5 equals 0, so r is equal to 5. Now, which of those answers makes sense? When we come to the diagram, well, r is a measurement of length. We can't have a negative measurement of a radius. So the value for r that we're going to take for any of the rest of our question is going to be 5. So going back to my centers for both of these circles. So the center of C1, if r is 5, then that's going to be 10, 17. And it will have a radius for C1. The radius will be 10, so 2r. If we look at the center of C2, then that's going to be 19, 5, and the radius will be 5. So that's all the information that we need in order to write our equations of our circles. So we can write it as x minus 10 to be squared plus y minus 17 to be squared is equal to 100. So if we remember our equation of a circle, this is my r squared. So that's where 10 squared is 100. And C2, x minus 19 to be squared plus y minus 5 to be squared is equal to 5 squared, which is 25. And those are my two equations of the circles, and that question was worth 10 marks. B part 2 asks us to find the coordinates of P. So P is the point at which the two circles are touching. And what we understand about P is that it's the point that divides the line between the two centers into a ratio of 2:1. And in our log tables book, we have a formula on page 18, which talks about dividing a point dividing in a ratio A is to B. So we're going to use that formula to help us answer this question. So in this case, we're using the points 10, 17, my center for C1, and we're using the point 9, 5. And my ratio here is 2:1. So my x1 and y1 are 10, 17, my x2 and my y2 are going to be the 19, 5, and we have AB is my ratio. Filling into my formula then, we are going to say that P is equal to 1 times 10 plus 2 times by 19 over 1 plus 2. And 1 times 17 plus 2 times 5 over 1 plus 2. So simplifying what we can there, we end up with 10 plus 38 over 3, and 17 plus 10 over 3, which simplifies to 48 over 3, 27 over 3. And again, simplifying to 16, 9. And that's my point P. And that was 5 marks. Question 4a, we have one of our mandatory proofs here. And we're going to start by looking at changing tan of A plus B. And what we do know is that from page 13 in our log tables book, up here, the very first one here, we have tan of A is equal to sine A over cos A. So tan is equal to sine over cos. So I can rewrite this as sine of A plus B over the cos of A plus B. And from there, I can use my formulas on page 14 of the log table book. I have cos of a plus b and an expansion, and sine of a plus b and an expansion. So that's what I'm going to do. So instead of sine of a plus b, I'm writing sine a cos b plus cos a sine b all over cos a cos b minus sine a sine b. Okay, from there, let's have a look at what we've got and a look at what we're expected to write. And the one thing that I would look at is this first term in the denominator. We have a 1. And after that 1, we have a minus. Now, we have that minus already. That means this first term here, the cos A cos B, has to become 1 in some way. Now, the main way to make that 1 would be to divide it by itself. But I can't just divide one part of this fraction by itself. I must divide the whole fraction by the same thing, top and bottom, and every part of it. And that's going to be the next step. Okay, I'm going to divide everything that I see here within this fraction, each of the terms on the top and the bottom, by cos A cos B. So that's going to look like this. Sine A cos B over cos A cos B plus cos A sine B over cos A cos B. Now, not only will this allow me to get 1 in the denominator, it will also help me in other ways as well. So here on the bottom, we have cos A cos B divided by cos A cos B minus sine A sine B over cos A cos B. So once I have divided everything by the same thing, I'm not changing its value in any way, I am just changing and manipulating how it looks. So this will cancel, this all will cancel and leave me with just 1, which is perfect. On the top, if we have a look, we have cos B on the top here and cos B on the bottom of that fraction. They will cancel each other out. And over here, we have cos A and cos A on the top and bottom of that fraction. So what am I left with? I have sine A over cos A plus sine B over cos B all over 1 minus. Now, nothing cancels here. But what I am going to do is I'm going to split this fraction up a little bit, just how I write it. So I'm going to write it as sine of A over cos of A and sine of B over cos B. Now they're still multiplying by each other, so in theory it has the same value. I'm just writing it in a different way. And the reason why I'm writing it in a different way, if I go back to the first original step that we made, we wrote tan of an angle as sine of the angle over cos of the angle. Well, here we have sine of A over cos A. So that means that that is exact same as tan A. We have sine of B over cos B, which is the exact same as tan B. We now have the numerator we're looking for. We have the 1 and the minus, and here are my two fractions. And the reason why I've written them separately to help you, you don't necessarily have to do this. If I just take this first bracket that's being multiplied, I can write that as tan A, and the second bracket is tan B, and they are multiplying by each other. And there I have completed my question. And that is worth 10 marks. Part 2 gives us a diagram, and it shows that we have the measurement of an angle of PQR is 90 degrees, so we have a right angle triangle. We have PQ is 3 units, QT is 2 units, and TR is also 2 units. And again, all that information is on the diagram. We're asked to use the formula from part A, part 1, and without using a calculator, find the value of tan of y, giving our answer in a fraction m over n, where m and n are natural numbers. So using the formula for part 1, I mean, even if we didn't answer part 1 correctly, we have that formula there, which is helpful. Okay, even if we're not sure where to start here, look at the diagram. What can I tell from the diagram? What can I write down? What information can I show the examiner I understand? So you have a right angle triangle. We have angles being referred to, and we have some side measurements. So I'm going to start off with this small triangle here, the triangle PQT. And if I look at the information that I have an angle of x. Opposite that, I have a measurement of 2, and adjacent, I have a measurement of 3. So I could tell you that the tan of the angle x would be equal to 2 over 3. I'm using tan, I suppose, because I'm focusing in on the fact that the formula that we've just worked on is in tan, and also they're looking for a value of tan of y. So that all seems to make sense. Then if I look at the overall triangle that I have here, I have x and y. Okay, I have two angles being added together. So you could say that I'm talking about the tan of x plus y. And again, that all seems to make sense, bearing in mind that I'm using the formula from part 1. So I have two angles being added together. And if I look at the tan, my opposite in this case will be 4, and my adjacent will be 3. So those are two pieces of information that I can take from the diagram. Now if I apply the formula from part 1, so I know that the tan of x plus y would be equal to the tan of x plus the tan of y all over 1 minus the tan of x multiplied by tan of y. So I'm going to fill in what I can into that formula. So tan of x plus y is 4 over 3. And that's equal to the tan of x, which is 2 over 3, plus tan y, which is what I'm looking to find, over 1 minus the tan of x, which is 2 over 3, multiplied by the tan of y. Now, having fractions within fractions can make it a little bit tricky when we look at it. So what we could do here is multiply the top and bottom of this fraction by 3, just to eliminate the 2/3 within that fraction. You could do it now, you could do it a little bit later on. It really doesn't matter as long as we do it correctly. So if I multiply the numerator there by 3, I'd get 2 plus 3 times tan of y over 3 minus 2 tan y. Just makes it a little bit tidier and neater. When I have two fractions equal to each other, I'm going to cross multiply. So 4 times 3 minus 2 tan y is equal to 3 times 2 plus 3 tan y. Expand out what we have there. We have 12 minus 8 tan y is equal to 6 plus 9 tan y. We'll bring our tans together and numbers to the other side. We would end up with 6 is equal to 17 tan y. So 6 over 17 is equal to the tan of y. And that is exactly what we're asked for. Leave your answer as a fraction, m over n, where m and n are natural numbers. And that question was worth 5 marks. Part B gives us a triangle, and we have the lengths of the sides are consecutive integers, meaning they are one after the other. And the measure of the largest angle is twice the measure of the smallest angle. And all that information is referred to on the diagram. So the first part is asking me to use the sine rule to find an expression for cos A in terms of x. So if I look at my diagram, I have options here of what I want to label. If you normally label your A, B, and C, that's absolutely fine. It really doesn't matter. So say, for example, I label that A. This is my side A. This could be my angle B, side B, and C, side C. Okay. For the sine rule, I need an angle and a side opposite. I have two pairs of that. So I'm going to say that x over the sine of A is equal to x plus 2 over the sine of 2a. Now, the sine of 2a, if I use my log tables book, and again I'm looking at page 14, I can rewrite the sine of 2a as 2 sine a, say. So that's what I'm going to do now. So x over sine a is equal to x plus 2 over 2 sine a cos a. And now I'm going to cross multiply. So x multiplied by 2 sine a cos a is equal to x plus 2 times sine a. Multiplying that out, what I can do, well actually, what I can do here is, if I have a look, I have a sine a on that side being multiplied and a sine a on that side being multiplied. I could actually cancel that out straight away. I could cancel it after I multiply it out. It really doesn't matter, but it just makes it a little bit nicer if I can do it now. So multiplying that in, I get 2x cos a is equal to x plus 2. If I want to solve or get sorry, a cos a in terms of x, so cos a will be equal to x plus 2 all over 2x. So again, I'll write that out again. Cos of a is equal to x plus 2 over 2x. And that is worth 5 for x. We're now asked to use the cosine rule to find an expression for cos a in terms of x. So using my cosine rule, if I go back up here, I already have my side A labeled, and that works out beautifully for what I want to find. I want to get cos A in terms of x, and then I have my A, my B, and my C all labeled. So filling into our cosine rule, we would have x squared equals x plus 2 to be squared plus x plus 1 to be squared minus 2 times x plus 2, x plus 1 cos A. And I usually will put that into a square bracket because I want to make sure that I work that out correctly first. Okay, from here we can do some expanding. So x squared will be equal to x squared plus 4x plus 4 plus x squared plus 2x plus 1 minus 2 times x squared plus 3x plus 2 times the cos of A. Simplifying a little bit, we end up with 2x squared plus 6x plus 5 minus 2 times that bracket. Okay, we're trying to isolate cos of A by itself. So the first thing I'm going to do is, I suppose, move as much as I can to the other side of the equals to sign. This is at the moment negative. What I can do here is actually make that a positive. So I'm going to write it as 2 times x squared plus 3x plus 2 times cos A. And I'm going to be left with the 2x squared, and then minusing that x squared, we end up with x squared plus 6x plus 5. So just rearranging it to make everything positive. I'm just trying to start the isolating of cos A by itself. So the next thing I'm going to do is this bracket here. I'm going to divide it. So 2 times cos A will be equal to x squared plus 6x plus 5 over x squared plus 3x plus 2. Okay. Now actually what we end up with here, an algebraic fraction, what we can look to do is to factorize. And actually what we realize is maybe we could have left these two brackets here as they were, because I'm actually going to put them back into the brackets. The top factorizes as x plus 1 by x plus 5, okay? And here we would have x plus 2 by x plus 1, which is what we had originally. The reason for that is my x plus 1s will cancel, okay? So I'm left with 2 cos A being equal to x plus 5 over x plus 1. I don't want 2 cos A, I want just cos A. I'm just going to write it down here. The cos of A then will be equal to that 2 is going to have to divide. And if it's dividing, it's going to go into the denominator on the other side. So 2 times x plus 1. And that is my answer. And that was worth 5 marks. Last part of question 4 is asking me to hence find the value of x. So what we have here from the previous 2 parts of the question is cos of A. 2 different ways of expressing cos of A in terms of x. So the easiest way for me to find the value of x is to put those equal to each other to start off with. So my x plus 2 over 2x from part 1 and my x plus 5 over 2 times x plus 1 from part 2. If I cross multiply, I end up with 2 times x plus 2 by x plus 1 equals 2x times x plus 5. And now I need to expand that out. So 2 times x squared plus 4x plus 4 is equal to 2x squared plus 10x. We want to get this or solve as best we can. Now actually what we realize when we multiply this side out, we actually end up with 2x squareds. And that means that actually the x squareds cancel each other out because we've got a 2x squared on this side, 2x squared on this side. They can cancel each other out. If I was to rearrange them, one would become negative and we would get 0. So we actually end up with 8x plus 8 equals 10x. Getting the x's to one side, then we would equal 8 would equal 2x. 10 take away 8. Well, if 8 equals 2x, then x equals 4. And that part of the question is worth 5 marks. Question 5a, we're given that ABCD is a parallelogram and M is the midpoint of BD. XY is any line through M, where X is an element of AD and Y is an element of BC. We're asked to prove that MX, so this section here, is equal to MY. And the way that I'm going to go about doing this is by proving that we have 2 congruent triangles. So the triangles that we're looking at, if I draw them out, the first triangle is the triangle BMY, which we can see nice and clearly here at the bottom. And we're also looking at another triangle, which I'm going to draw in the exact same orientation as BMY, and that is the triangle that's up here. And I'm going to draw it as DMX. And hopefully in drawing it like that, we can hopefully start to see a little bit of the congruency. So the first thing we're going to look at is there anything that's given to me, any information? And the first piece of information is that M is a midpoint of BD. Well, if that's a midpoint, then BM, line segment and length BM, is equal to then MD. Why? Because M is a midpoint. Okay, midpoint of BD. Okay, so we have 2 sides equal. So marking it on my triangles, that's what we're talking about. We also have then an angle. So the angle that I'm going to start talking about first is this one here. And we have the angle MBY, and that is equal to the angle MDX. This angle here. And why is that? Because we have alternate angles. So we have proven that a side is equal in both of these and an angle is equal in both of these. Then the next thing we're going to look at is another angle. We're going to have a look at the angle BMY. So BMY is this angle here. And we're going to say that that angle is equal to the angle DMX. Again, this angle here. And why is that? Because they are vertically opposite angles. Again, looking back at my parallelogram, we're talking about this angle here and this angle here. My alternate angles of MBY are here and MDX are there. Okay, so hopefully we can see that from the original diagram as well. Remember, this is a parallelogram. Okay, so we have proven that we have two angles that are equal, and we also have a side measurement that's in between. So the triangle MBY is congruent to triangle MDX. And that's through angle side angle. So therefore, MX is equal to MY. And that question was worth 10 marks. B, we're given the triangle that UVW is the image of the triangle PQR under an enlargement with a center O. And the area of PQR is 8 centimeters squared. The area of UVW is 24.5 centimeters squared. So the first thing we're asked to do is find the scale factor of the enlargement. So when it's an area scale factor, it's always going to be squared. So if I put my area scale factor here, for example, as k squared. So a linear scale factor would just be k. Area scale factor k squared. If we were talking about a 3D shape and a volume scale factor, we're talking about k cubed then. So k squared when it's a area scale factor. And what we know is that 8 multiplied by that scale factor must be equal to 24.5. That's the information that they've given to me in the question. So k squared will be equal to 24.5 divided by 8. So k will be equal to the square root of that, which is 7 over 4 or 1.75. And that was worth 5 marks. Given that the length UW is equal to 5.25 centimeters, we're asked to find the length of PR. What we just found in the previous part of the question, that k is equal to 1.75. Remember what I explained to you. If k squared is my area scale factor, k is the linear scale factor. So if the measurement of UW is 5.25, we know that k is equal to 1.75. And again, k is my linear scale factor. So any measurement of length in the smaller shape can be multiplied by 1.75 to get the length, corresponding length in the larger shape. So that means that whatever PR is, the length PR, if we multiply it by 1.75, we know that we will have an answer of 5.25, because that's what it tells me in the question. So PR then can be worked out by doing 5.25 divided by that linear scale factor of k. And that is an answer of 3. And that is 5 marks. Part C gives us a diagram where we have a right angle triangle. The angle EFG is 90 degrees. We have a measurement EF, which is 12 centimeters, and a measurement of FG, which is 16 centimeters. We're told that M is the midpoint of the line EG, and the angle NME, so this angle here, is 90 degrees also. So the first thing we're asked to find is the measurement of MN. Well, like with any diagram question, if we're given information like this, the first thing I would do is what can I find that I don't have from this? Now, if I'm looking to get MN, I'm going to need some other measurements that are here. I probably might need this measurement of EM. I know that M is a midpoint of the line EG, so maybe we look to see, can I find out? I do have enough information to use Pythagoras here. So EG squared would be equal to 12 squared plus 16 squared. Just using my overall right angle triangle of EFG that they've given to me. So EG squared would be equal to 400. So the line EG is equal to 20 centimeters. So that's the first piece of information that I found. So this measurement here from E to G is 20 centimeters. Well, I know that M is a midpoint, so that means that each of these segments here are 10. So I have a line here from E to M or M to E that is 10 centimeters. The next thing that I could probably find is, do I have any angles that could help me? Okay. So what I'm looking for here, I'm going to look at this angle down here because this line MN that I have to find is in this. If this is a right angle, then we know that this is a right angle here. So we have a right angle triangle here that maybe we can use to find that final answer we're looking for. But in order to do that, it would be useful to have an angle. And we're going to look at focusing on this angle because this angle is also in the overall right angle triangle that I have, of which now I have 3 of the sides. So I just do a quick sketch out of what I'm talking about. I'm looking at this angle here. I have a side measurement of 12, I have a side measurement of 16, and a side measurement of 20. So I've got 3 different options here. I could use sine, I could use cos, I could use tan. I'm going to use sine. And I'm going to find out what this angle is here. So I'm going to say that the sine of theta is equal to 12 over 20. So theta will be equal to the sine inverse of 12 over 20, which gives me an answer of 36.8699. Now I am going to keep all those decimals. Okay, I'm going to keep as much accuracy as I can in my question. So if I know this angle now, and I have a side measurement of 10, again, a little quick sketch out of that smaller triangle that I'm talking about that has M and N and G as its vertex. And we have a side measurement of 10. We know this angle here is now that 36.8699 that I've just found out. And I am looking for MN. I am looking for this measurement here, which I could call X if I wanted to make it a little bit easier to refer to. So what I can say is that the tan, because we're looking at opposite over adjacent, remember this is my right angle, the tan of that angle, 36.8699, is equal to x over 10. Now the tan of 36.8699 works out to be about 6.5 and lots of zeros is equal, and then multiplied by 10, sorry. So that's when I bring up the 10 and multiply, gives me x. So 7.5 is equal to x. So just to clear that up, bringing the 10 up and multiplying at the same time. So I could put in an extra line there of 10 times the tan of 36.8699 is equal to x. So multiplying by 10 and working out the tan of 36.8699 gives me that 7.5000, so on. So x is equal to 7.5, and x being my MN. And that is worth 5 marks. Part 2 asks me to find the area of the triangle EFN. So if we go back up to our diagram, EFN is this tallish kind of right angle triangle here. And how I'm going to find the area is to find the overall area of the triangle EFG. And I'm going to then find the area of the triangle ENG, which is this one here. And I'm going to take one away from the other, and that should leave me with the area that I'm looking So EFG, I've just already written this down. The triangle EFG, base times height divided by 2 will give me 96 centimeters squared. So the next triangle I'm looking at is the triangle ENG, and that has a base of 20, and it has a height of 7.5. So that's using all information that I found in parts 1 and 2, parts 1 of this question, and we're dividing by 2. So 75 centimeters squared is my answer for the area of the triangle ENG. So if I wanted to find out the area of the triangle EFN, I'm going to do 96 minus the 75, and that leaves me with an area of 21 centimeters squared. And that question was worth 5 marks. Question 6, we have the Venn diagram below shows 3 events and their associated probabilities. B and C are mutually exclusive events. A and C are independent events. So the first thing here, if B and C are mutually exclusive events, it means they can't happen at the same time. So when we're talking about B intersection C, that would be equal to the null set then. Okay, there should be nothing within this section. So the probability of B intersection C is 0. That means x must be equal to 0. That's our first solution. So x equals 0. We're here finding the values of x, y, and z. The next thing that we're told is that A and C are independent events. So that means that the probability of A intersection C will be equal to the probability of A multiplied by the probability of C. So, probability of A intersection C is Z and 0. We put that equal to the probability of A, which is 5 over 24, plus Z plus Y, multiplied by probability of C, which is 1/6 plus Z plus 0, because remember x is also 0. So simplify what we can. We end up with Z is equal to 5 over 24 plus Z plus Y multiplied by 1 over 6 plus Z. And we just leave it at that for now. The next thing that we will look at is the full universal set, S. And what would be the probability of the universal set? So the probability of S. And that's going to be equal to all of the probabilities, all of what we see in our Venn diagram. So we're looking at 5 over 24 plus Z plus Y plus 1/4 plus X plus 1 over 6 plus 1 over 12. Okay, and we can obviously do some simplifying there. So the probability of S will be equal to, bringing our fractions together, 17 over 24 plus Z plus Y, and remember x is 0. And what we should understand is that the probability of the universal set will be equal to 1. All probabilities add up to 1. So in this case then we can say Z plus Y is equal to 1 minus the 17 over 24, which gives us 7 over 24. What we can do then is, we have Z plus Y here, we have that equal to 7 over 24. If I go back up to what we had here, we have a Z plus Y here. And what we're going to do is we're going to substitute in, where we see Z plus Y, we're going to substitute in for 7 over 24. So Z will be equal to 5 over 24 plus, now I'm going to replace it with 7 over 24 multiplied by 1 over 6 plus Z. And we multiply that out, we end up, or whatever we're left with a half multiplied by 1 over 6 plus Z, which is 1 over 12 plus a half z. Now, if I just go back up here, if I manipulate that a little bit more, what I can say is that half z is equal to 1 over 12. Where am I getting that from? Well, if I rearrange this, z is equal to this, bring over or take away half z from both sides, I'm going to end up with a half z is equal to the 1/12 here. So z is equal to, multiply both sides by a half, and we would get 1/6. So we now have x is equal to 0, z is equal to 1/6. And what I can use now is that z plus y is equal to 7 over 24. So 1/6 plus y is equal to 7 over 24. So y is equal to 7 over 24 minus 1/6, which is 1/8. And those are my answers. X is 0, y is 1/8, and z is 1/6. And that question was worth 10 marks. Part B, the average mark of all students in a school who participated in a maths quiz was 70.6. The mean mark of 6th-year students was 73, and the mean mark of 5th-year students was 69. What percentage of the participants in the maths quiz were 6th-year students? So if I say that 6th-year students, the total number of students in 6th year that did the maths quiz, we call that X, and for 5th-year students, we'll call that Y. So if the total, the average of all the students who did the maths quiz, so that would be 5th and 6th year combined, is the average they got was 70.6. So X plus Y representing the total number of students who sat the quiz, multiplied by their average of 70.6, will be equal to the 6th years scored an average of 73. So X multiplied by 73 plus the 5th year scored an average of 69. So Y multiplied by 69. And if I expand that out a little bit, I get 70.6x plus 70.6y is equal to 73x plus 69y. And now I'm going to I can choose to either make x or y the subject here. I'm going to choose to make y the subject. So what I would end up with is bringing the y's to one side and the x's to the other. I'll end up with 1.6y is equal to 2.4x. So y could be written as 2.4x divided by 1.6. So if I want to find out what percentage of the participants in a maths quiz were 6th years, I'm representing 6 years as x. So we're talking about x students over the total, which is x plus y. I now have a way of filling in for that y in terms of x. So I can write that as x over x plus 2.4x over 1.6. If I bring that together and simplify, I'll end up with x over 2.5x, which is, if I cancel my x's, 1 over 2.5, which is 0.4. Now that's it as a decimal. If I want to make that a percentage, multiply by 100. So I end up with an answer of 40% our 6th year. That question was worth 10 marks. Part C, a bowl contains 15 pieces of paper, each of which is numbered 2, 5, or 8. There are twice as many pieces of paper numbered 2 as there are pieces of paper numbered 8. One piece of paper is selected at random from the bowl and then replaced. The process is repeated several times. If the expected value of the number selected at random from the bowl is 4.2, we're asked to find how many pieces of paper are numbered 5. So when we don't know how many are a given number, for example, we don't know the number of 8s, so the number of pieces of paper numbered 8. And when we don't know something, we'll call it x. Okay, so for example, we'll go with the 8s as x. The number of 2s we will represent as 2x, because we're told in the question there are twice as many pieces of paper numbered 2 as there are pieces of paper numbered 8. And lastly, the amount of pieces of paper that are have the number 5 on them. Okay, so the number of 5s will be the total number, which is 15, minus what we've already represented, which is 3x. That's our first step. So the probability of picking a piece of paper number 2 is 2x over 15. The probability of picking a piece of paper numbered 5 is 15 minus 3x over 15. And the probability of picking a piece of paper numbered 8 is x over 15. So we're told that our expected value is 4.2. So we can write that as 2 multiplied by 2x over 15 plus 5 multiplied by 15 minus 3x over 15 plus 8 over x plus 15 is equal to 4.2. So when we simplify that out or expand out our brackets, we get 4x over 15 plus 75 minus 15x over 15 plus 8x over 15 equals 4.2. We have a common denominator here of 15, but if I multiply across by 15, I can get rid of the fraction. So 4x plus 75 minus 15x plus 8x equals 63. Bringing our x's together, we get minus 3x is equal to and minus 12 on the other side. So 3x is positive 12, x is equal to 4. So if x is equal to 4, then 15 minus 3 times 4 gives us an answer of 3. So 3 pieces of paper are numbered 5. And that was worth 10 marks. Question 7 part A, we have a vertical clock tower has a large circular clock face mounted vertically on a tower wall from a point P on the same level as the base of the tower B. The angle of elevation of O, the center of the clock face, is 24 degrees. From a point Q 10 meters vertically above P, the angle of elevation of O is 20 degrees. All that information is on the diagram. So we're asked to work out h, the height of the center of the clock face above ground level, and give our answer correct to the nearest meter. So the first place I would start here is we have a right angle triangle with the angle of 24 degrees marked with O, P and B. So looking at how we might find the height there, our h is our opposite, this is our adjacent, and obviously we have our hypotenuse here. Okay, our h. Now one piece of information that I don't have at the moment is this distance here of PB. But if I was to put in, for example, the tan ratio, tan of 24 degrees would be equal to our OB here, which is our h, over our length PB, which we don't yet know. And what I could do there is I can manipulate that a little bit. I can make PB subject, making that or writing that as h over the tan of 24 degrees. Now we also understand we have another triangle here. If we take OQ, and if we were to continue on our line there, meeting at a point here, which we could call whatever, another right angle triangle, okay? That also involves the same length here of PB. The height of this triangle will be h minus the 10 meters that's given to me here. So h minus 10 up to this point. So we could call it OQ and just any other letter, maybe T, for example. Okay, so our right angle triangle there is what we're going to focus on now. So if I treat it the exact same way, I could say tan of 20 degrees is equal to our opposite, which is h minus 10 over our adjacent. Now instead of calling it QT, I'm going to also call it the length PB because it is the exact same length. And again, I'm going to make PB the subject, and I can write that as h minus 10 over the tan of 20 degrees. And what that allows me to do, I now have two fractions that represent PB, and I can put them equal to each other in order to try and solve for h. So h over the tan 24 degrees is equal to h minus 10 over the tan of 20 degrees. If I cross multiply, h tan 20 degrees is equal to h minus 10 times the tan of 24 degrees. Multiplying out the right hand side, expanding out that bracket, I get h tan 24 degrees minus 10 tan 24 degrees. And I want to try and isolate and bring my h's together. So if I do that, I'm going to take away h tan 24 degrees from both sides. And then I can factorize by taking h out. So leaving me with tan of 20 degrees minus the tan 24 degrees inside a bracket. And in order to find h, I'm going to divide both sides by that bracket. And we can use our calculator to find our answer. And we should get an answer of something like 54.7916 and so on. And they ask us to give this correct to the nearest meter. So correct to the nearest meter is 55 meters. Apologies there if you couldn't see the bottom line. Okay, so make h the subject. That means we bring over this bracket and divide. Fill that into our calculators nice and carefully. We get 54.7916. Correct to the nearest meter comes out as 55 meters. And that question was worth 10 marks. Part B, we're asked to find the angular speed of the minute hand of the clock, giving our answer in radians per minute, i.e. the number of radians turned around in 1 minute. So if we think about our clock face, it's a circle of 2 pi. So it turns 2 pi radians in 60 minutes, in 1 hour. So in 1 minute, it will turn then 2 pi divided by 60. And 2 pi divided by 60 is pi over 30. So it turns pi over 30 radians per minute. And that question was worth 5 marks. In part C, we're told on the clock face the minute hand is 2.4 meters long. The height of the tip of the minute hand above ground level is given by the function. So we have h of t is equal to a plus b cos ct, where a, b, and c are elements of the real numbers. Where t represents the number of minutes since 4 p.m. and ct is expressed in radians. So we're asked to work out the values of a, b, and c. Well, we already know that the center of the clock face is 55 meters above ground level. Okay, so from ground level to that point there is 55 meters. So 55 plus 2.4 gives me a height of the tip of the minute hand of 57.4 meters above the ground. So at 4 p.m., the tip of the minute hand is 57.4 meters above the ground level. Okay? At 4:15 p.m., so a quarter past, if I was to just sketch out my minute hand there, we know that that tip of the minute hand is 55 meters above the ground level because it's in line with that center of the clock face. Now the angle that it's turned to get to the quarter past in radians will be an angle of pi over 2. Okay, so we're going to use this information now and fill it back into our function that's given to us. So we know at 4 p.m. that's when t is equal to 0. The clock or the minute hand hasn't moved. So when t is equal to 0, we have a plus b cos of 0. And we know that that's equal to 57.4. Cos of 0 is 1. So we end up with a plus b is equal to 57.4. We know that when t is equal to 15, so quarter past 4, a plus b times the cos of pi over 2, which is the angle that's created by moving those 15 minutes, that will be equal to 55. When I work this out, I end up with a plus 0, so a is equal to 55. So there's one of my solutions straight away. Now if a is equal to 55, a plus b gives me the 57.4, so b must be equal to 57.4 minus the 55. Okay, so b is equal to 57.4 minus my 55, which actually gives me back my 2.4, which is the length of the minute hand. So b is 2.4. Now when we look at this function, our c is multiplying by t. T representing how many minutes? C has to be how much in radians each minute is. We already said that it moves at pi over 30 radians per minute. So C here has to be pi over 30. Each minute on the clock is pi over 30 radians. That question in total was worth 10 marks. Part 2 in C, we're asked to complete the table below to show the height of the tip of the minute hand above ground level between 4 o'clock and 5 o'clock, so 4 p.m. and 5 p.m. Two of the heights are given to us. So at 4 o'clock, we already worked out in the last part that that will be at 57.4 meters. We also know that at 5 o'clock, it should also be 57.4 meters because it's come back to the starting point again. To get any of the figures in between, what we have to do is fill into our formula. So for example, when t is 20, so 20 minutes after 4 o'clock, we're going to fill into the function that's given to me. So 55, which is our A, plus 2.4, which is our B, times by the cos of pi over 30 times 20 in this case for t. Okay. Now when we fill that into our calculator, we will get 53.8. And we do that for t being 30 and t being 50 as well. So those values should end up being 52.6 and 56.2. And that's our completed table. Now this particular part of the question is linked to the next part, which is graphing it. Okay, so the marks go for both. So now let's look at the graph and see what we need to do. So having turned over the page, we can see that we're asked in part 3 to sketch the graph of h of t between 4 p.m. and 5 p.m. So firstly, let's look at our scales. We have our time on our x-axis and we have our heights on our y-axis. Just important to note down what scaling it's going up on. So for example, if we have a gap between 40 and 45, then we know in between that's going to be 42.5. Here will be 47.5, 52.5, 57.5, just so we make sure that we're okay with what we're having to sketch. So our first value that we need to do is 4 o'clock. It should be at 57.4. So we draw it as plot it as accurately as we possibly can. At 4:10 is 56.2. So somewhere right there. At 20 past 4, we're at 53.8. At 4:30, we're at 52.6. At 4:40, we're back up to 53.8. 4:50, 56.2. And the last one then back up in line with the first one of 57.4. And what we need to do then is join those together as carefully as we can. Should be done freehand. And we have our sketch of our graph. So this graph and also the table before together are worth 5 marks. Part D, on the clock, the minute hand is 2.4 meters long. The hour hand is 1.6 meters long. Work out the angle between the tip of the minute hand and the tip of the hour hand at 4:10 p.m. So, first thing we could look at is our minute hand. If it moves to 10 past 4, what angle is being created there? So we have 10 minutes, and each minute is pi over 30. So the minute hand will have moved pi over 30 times 10, which works out as pi over 3. Okay, so that angle there is pi over 3. Our hour hand we have not looked at the angular speed for the hour hand, but we know that in 1 hour, 60 minutes, the hour hand will move the same amount as 5 minutes. Okay, the same kind of distance as 5, so it moves at a much slower pace. So it moves at a rate of 5 times pi over 30, which works out as pi over 6. So in 60 minutes, it will move pi over 6 radians. So in 1 minute, it will move pi over 6 divided by 60, which is equal to pi over 360. So in 10 minutes, we multiply that by 10. 10 times pi over 360 will be equal to pi over 36. Now, what does that represent? So when our minute hand moves to 10 past, the hour hand will have moved slightly, and the angle that it creates with its original or starting position, this angle in here, is my pi over 36. So the angle, original angle of the minute hand and the hour hand at 4 o'clock. So its starting point is a distance of 5, 10, 15, 20 minutes around on the clock. So that's 20 multiplied by pi over 30, which is 2 pi over 3. So that was the original starting angle between the two hands. But at 4:10 p.m., it will be that angle plus the pi over 36 that the minute hand, or sorry, the hour hand moved, minus the pi over 3 that the minute hand moved. And we get a final answer of 13 pi over 36. And that question was worth 10 marks. We're then asked to hence find the distance between the tip of the minute hand and the tip of the hour hand at this time, and give your answer correct to 2 decimal places. So the best way to try and start this question, I think, is to do a quick sketch. So if we let that line represent our minute hand, and we draw a line here representing the hour hand. We get a straight edge, and we join those two tips together, we have a triangle. This length here we know is 2.4. This length here is 1.6. And our angle in here that we've just found is 13 pi over 36. So we have a triangle, and they want us to find this distance here. It's not a right angle triangle. We have two sides. We have an angle in between, and we're trying to find the third side, which is opposite the angle that we have. So hopefully we'd all recognize that that would be our cosine rule. So labeling the angle that we have as A, side opposite as lowercase a, and it doesn't really matter for the other two. So we can call them B and C as we look at it. So putting into our cosine rule, A squared is equal to 1.6 squared plus 2.4 squared minus 2 times 1.6 times 2.4 times by the cos of 13 pi over 36. So A squared is equal to 8.32 minus 2 times 1.622854. So A squared is equal to 5.07429175. A will be equal to the square root of that, which is 2.25261, and to 2 decimal places, 2.25 meters. And that question was worth 5 marks. The last part of question 7 asks us to find the first time after 4 p.m. when the minute hand and the hour hand overlap, and give your answer correct to the nearest second. So let's go back and look at some of the things that we've already worked out. So our angular speed of the minute hand we worked out as pi over 30. So after t minutes, that's multiplying pi over 30 by whatever t is. We also worked out that the angular speed of the hour hand was pi over 360. So equally after t minutes, we would multiply pi over 360 by t. So the angle between the hands at 4 p.m. was 2 pi over 3. So to find out when they will overlap, we will look at putting the pi over 30t equal to the angle that they start at plus our pi over 360 times t. First thing we will do here is multiply by 360 all the way across. So we get 12 pi t is equal to 240 t, pi plus pi t. We could also divide across by pi as well. So it's a common term in everything. So we end up with 12t is equal to 240 plus t. So bringing our t's together, 11t is equal to 240. So then t will be equal to 240 divided by 11, which gives me 21.81. And it just keeps going, 81. So the time will be 21 minutes. And if we work out 0.81, it works out as 49 seconds. So after 21 minutes and 49 seconds, so if I add that to my 4 o'clock, we're looking at a time of, if you want to write it in the 24 o'clock, we're looking at 16:21:49 as being our time when the two hands will overlap. And that part of the question was worth 5 marks. Question 8 gives us that a wooden toy rocket is in the shape of a cone on top of a cylinder as shown in the diagram. So the conical part has a diameter of 16, a height of 15, the cylindrical part has a diameter of 10 and a height of h. And the volume of the cylindrical part of the toy is 125% of the volume of the conical part. So the first part of this question that they're asking me to do is to work out the curved surface area of the cone in terms of pi. So if we look on our log tables book on page 10, we have a cone and we have a formula there, pi r L, which gives me the curved surface area of a cone. So that's what I'm going to use. So my area is equal to pi r L. Now what I don't have is my L, and L being this length here. So looking at that for a second, if I take out a right angle triangle, with this being L, my height of the cone, we're told, is 15. The diameter is 16, meaning the radius is 8. So I can use Pythagoras here because this is a right angle triangle. And I can say that L squared is equal to 15 squared plus 8 squared. So L squared will be equal to 289. L is equal to the square root of 289, which is 17. So filling into my area formula then, I will have pi multiplied by 8, the radius, and now L, which is 17. So my area in terms of pi will be 136 pi centimeters squared because we're talking about area. And that question is worth 5 marks. Part 2, then we're asked to work out the volume of the cone and hence find h, the height of the cylinder. Well, if again I look at page 10 of my log tables book, my volume formula for a cone is 1/3 pi r squared h. So filling into that, we have 1/3 pi times 8 squared, and my height of my cone is 15. So my volume will be equal to 320 pi centimeters cubed. So that's the first part of the question completed. It then asks me to hence find h, the height of the cylinder. So what we're told in the question is that the volume of the cylindrical part of the toy is 125% of the volume of the conical part. So that means that the volume of the cylinder is 1.25 times 320 pi. So 1.25 times the volume of cone part, which is equal to 400 pi. My volume of a cylinder formula is pi r squared h, and we know that that answer is 400 pi. I can cancel the pi's on both sides, and I can also substitute in my radius of the cylinder, which is 5. So 5 squared times by h is equal to 400. That means that 25h is equal to 400, so h is equal to 60. And that question was worth 10 marks. So part 3, the conical part of the toy, including the underside of the cone, which is partly exposed, is painted red, and the cylindrical part of the toy, including the base of the cylinder, is painted blue. We are asked to find the ratio of the area painted red to the area painted blue and give our answer in its simplest form. So let's split this up into 2 parts. We're looking at, first of all, calculating what area of this is red. So if we're talking about the cone, we know that the curved area of the cone, we found out in a previous question in part 1, is 136 pi. So that's the curved part that is red. We then have this part, which is on the underside of the cone, which is partially exposed. So basically it's the kind of overlip where the cone is attached to the cylindrical part. Now looking at the information, if I just talk about the base of the cone for a second. So the base of the cone is a circle, and the area of that would be pi times 8 squared, and 8 being the radius of the cone. So that's 64 pi. We know that not all of that is exposed, so not all of that is painted red. We have the top of the cylinder, which again is also a circle, and that part is covering some of this area. So we don't see all of the area of the base of the cone. So the top of the cylinder, its area would be pi times the 5 squared, which is 25 pi. So the base of the cone that is red would be 64 pi minus that 25 pi. So that's going to be 39 pi. So that's just like the overlip of the actual toy that's showing that is red. So the total area that is red will be 136 pi plus that 39 pi. And that gives me 175 pi. So that's just the part that's red. We then want to look at the area that is blue, which should be a little bit easier and a bit more straightforward. So what we're looking at is the surface area of the cone. And the surface area of the cone is, not the cone, sorry, the cylinder is 2 pi RH, and we have one circle. Okay, so that's the curved part of the cylinder. We have one circle on the base that will also be coloured blue. So that's going to be plus pi r squared. Okay, so we're ignoring the top of the cylinder as you cannot see that. So filling in our information that we have, 2 times pi times 5, the radius of the cylinder, times by the height, which is 16, plus pi times the radius again, which is 5 b squared. So we have 160 pi plus 25 pi. So the total that is blue, is 185 pi. So these are the two pieces of information and answers we're going to use, because now we need to put it into a ratio. And again, the order matters. So it's the ratio of the area painted red to the area painted blue. So that's going to be 175 pi is to 185 pi. The pi's can cancel each other out, and we want to simplify that, and it will simplify to 35 is to 37. And that's my final answer, and it's worth 10 marks. In part 4 here, we're asked to work out the volume of the smallest rectangular box into which the toy will fit. So if we wanted to do, we could do a bit of a sketch of what that box might look like and the measurements that it would need to be. So the smallest rectangular box would mean that there would be no space in, from the top, bottom, and on the sides. So basically the shape would fit in exactly into this box. So we would have to have a measurement that is exactly the width. So the longest width that we have is at 16 diameter of the cone part. Exact same when it comes to the depth of the box as well, because that cone, the diameter is not changing obviously. And the total overall height will have to be 31. Okay, so that is the length of 15 of the cone and the the height that we found of 16 previously in the question. So now that we have the 3 dimensions of the box, we're going to multiply them together to get the volume. So 16 by 16 by 31, which gives me a volume of 7,936 centimeters cubed. And that's 5 marks. Part B then gives us a diagram shown below of 3 identically cylindrical cans held in position by a taut cord A, B, and C at the centers of the cylinders, each of which have a radius of r. So the first thing that we're asked to find is to find the area of the shaded region between the cylinders. Give your answer in the form that's given there, where n is a natural number. Okay, so before we can go here, what can we do? Can we do anything with this diagram to help us out? And what I'm going to do is I'm going to join up centers of these circles, because I know that they all have the same radius. So if I join those 3 centers, what I create is a triangle. And the triangle is actually an equilateral triangle, because if they all have the same radius, then we can label them R. And what we find is that the distance between the circle centers is 2r. So each side measurement here is 2r. Because it's an equilateral triangle, I know that each angle is 60 degrees. So now I have a situation where I have a triangle and I have enough information here to represent the area of that triangle. So if I look at it, my area of the equilateral triangle would be equal to the half, I'm going to use half AB sine C. So half of 2r by 2r by the sine of 60 degrees. So I end up with, well, this gives me 4r squared, but if I divide that by 2, I get 2r squared multiplied by root 3 over 2. Simplifying that as much as I can, I get root 3 r squared. So that represents the area of the equilateral triangle. Now I don't obviously want the full area. I just want the shaded part in here. But I have 3 sectors of circles, and I can get the area of each of those sectors. So, area of the sectors of the circles that I have there inside the triangle can be represented by 60 over 360, because that's the fraction of the circle I have, using the angles to help me, times pi times the radius squared. I don't have the radius, so I'm just going to write r squared. And I have 3 of those sectors, so I'm actually going to multiply that by 3 now as well. When I simplify that down, I end up actually with pi r squared over 2. So that represents the area of the sectors, and that's the area that I don't want. So actually, if I want the shaded area, I'm going to take the overall area of that equilateral triangle. I'm going to take away the area of those 3 sectors. Okay? Obviously, I have to try and make this look like what they're asking me for in the question. That's reasonably straightforward because I have r squared in both of these. From here, we can see that r squared is outside of a bracket. So I'm going to factorize it by taking r squared out. And that leaves me inside with root 3 over 2 pi and r squared. And I'm writing it like that because that's how they have it in the question, centimeters squared. And that question was worth 10 marks. So part 2 here, I'm asked to find the total area of the region enclosed by the chord and giving my answer in that form, where P and N are elements of N. So in order to do that, I'm going to just go back to my diagram. So looking back at the diagram that I have, how can I work out the area of the region in total? Well, I already have this area here. So the equilateral triangle is covered. It's everything sort of outside of that now that's enclosed by the chord. But what I'm going to do is I'm going to create what shapes that I see. So here, what I'm going to create is a rectangle. And I'm going to do that actually all the way around. And I actually end up with, I have 3 rectangles within this shape. Okay. And what do I know about those 3 rectangles? Well, they have a length of 2r. So there's a measurement of 2r. And they have a width of r. Each of them are the same. Okay. So if I want to first of all find the area of those 3 rectangles, it's going to be 2r times by r, but I have 3 of them, so I'm going to multiply that by 3 as well. So the area covered by those 3 rectangles that are inside the chord is 6r squared. I already, as I have already said, my center triangle, I already know that the area of that equilateral triangle is root 3 r squared. So the bit that's left, if I turn back again, the bits that left are these sectors here on the very outside. But those are all the same. So if I just focus on that one down there for a second, if I know that this is 60 degrees, here we have rectangles. Those angles there are about 90 degrees. So if I take all of that information away from 360, I know that each of these angles is 120 degrees. Same here and same here. So I have 3 sectors all the same that have a radius of r and an angle here of 120 degrees. So I'm going to find the area of the 3 sectors. And that's going to be 120 over 360 multiplied by pi times the radius, again, r squared. And I have 3 of those, so I'm going to multiply that answer by 3 straight away. And actually that all simplifies down to give me just pi r squared. So if I want the overall or total area enclosed by this chord, I'm going to add these together. 6r squared plus pi r squared plus root 3r squared. And again, looking at the form in which I need to leave my answer, it's been factorized to leave r squared on the outside, so we do the same. R plus pi plus root 3 bracket r squared, and we're talking about area, so centimeters squared. And that was worth 5 marks. Last part of this question asked me to find the length of the cord holding the cylinders in position. And again, I'm given a form to leave my answer in. So looking back at my diagram for a second, the length of the cord is this perimeter all the way around the outside. I already know some parts of it, so I know that all these straight sides that are on the rectangles are worth 2r. What I don't have are these curved lengths. But I do again know that I have an angle of 120 degrees. And what I need to do is use my formula for the perimeter or circumference of a circle and find the fraction of that perimeter that I have. So what is that going to look like? Okay, so the length of my cord is going to be 3 times 2r, which are the straight sides of the rectangles, plus 3 times, I have 120 over 360, so that's my fraction of the circle I have, multiplied by my formula, that is on page 8 of your log tables book, for the length of the perimeter around a circle, 2 pi r. Okay, simplifying that, we end up with 6r plus multiplying here the 3 into this. Now these are being multiplied, so don't make the mistake of multiplying both of these elements here by 3. We only need to multiply one of them by 3. So if I multiply 3 into this fraction here, I actually end up with 360 over 360. So that just simplifies to give me 1. So I'm actually just left with 2 pi r. Okay, again, there's a multiplication here, not an addition. You don't need to multiply the 2 pi r by 3. What do I have? Well, this is what I have. This is what it needs to look like. Again, we're factorizing and taking the r out. So we're left with 6 plus 2 pi inside a bracket, r on the outside. It's a measurement of length, so it's just centimeters. And that is worth 5 marks. Question 9. In a particular country, it was found using the empirical rule that 95% of adult males had heights between 161.8 centimeters and 193.4 centimeters. In this part, we were asked to work out the mean height and the standard deviation for an adult male in that country and give your answer in centimeters. So if we're looking at the 95%, using the empirical rule, we're talking about the mean plus or minus 2 times the standard deviation. So we're told that the mean minus the two times the standard deviation, which is going to be our lower number here, will be equal to 161.8. The mean plus 2 times our standard deviation is equal to 193.4. So what we can do is, like we would do in a simultaneous equations question, these two will cancel each other naturally if I add. So when adding, I'm getting 2 times the mean is equal to 355.2. So the mean must be equal to that divided by 2, which ends up being 177.6. So that's the first of my answers. Now to find our standard deviation, we then use our mean. So we're going to use our 177.6. We know that if I take away 2 times the standard deviation, I get 161.8, for example. So if I rearrange that to make the standard deviation the subject, 177.6 minus 161.8 is equal to 2 times the standard deviation. So 15.8 is equal to 2 times the standard deviation. So 7.9 is what we can get for our standard deviation. And that question was worth 10 marks. Part 2 then said, using the empirical rule, work out the probability that a randomly selected adult male has a height in the range of the mean minus 1 times the standard deviation to the mean plus 3 times the standard deviation. So if we want to do a little sketch of what that would mean. So my mean is down through the middle. So there's my mean. If we're talking about minus 1 times the standard deviation, somewhere around there, 3 times the standard deviation will be a little bit further along here. Okay, just so we get a picture of what we have. So we know by the empirical rule that 68% of data is between the range of the mean minus 1 standard deviation and the mean plus 1 standard deviation. Okay, which is our starting point here that they're talking about. Now, the distance from the mean to here is half of that. Okay, so if I divide that by 2, I'm getting 34%. So just working out what's inside this area here first. Okay, 34% of data then will be between the mean minus 1 standard deviation and the mean itself. So just between these two here. I know that 99.7% of data is between the mean minus 3 times standard deviation and plus 3 times standard deviation. So again, if I was to widen out my range from here to here, example. Okay, we don't want this part here. We just want to know half of that information. So again, from the mean to plus 3 times the standard deviation, we're looking at half of this data. So again, if I divide by 2, we're talking about 49.85% of data. So here we're looking at this area from the mean to the point where it is the mean plus 3 times the standard deviation. Okay. So the probability of it having a height in the range of the mean minus 1 standard deviation and the mean plus 3 times the standard deviation is adding those two together. Okay, so probability of picking an adult male of height in the range the mean minus 1 standard deviation to the mean plus 3 times the standard deviation will be equal to 34 plus 49.85, both percentages. So when I add them, 83.35%. 83.35% of the data that we have is within that range. And that question was worth 5 marks. In the next part, we're asked to use our answers to part A, part 1 to work out the probability that a randomly selected adult male is taller than 190 centimeters. So the first thing we're going to do here is we're going to use our standardizing formula, which is on page 34 in our log tables book, which says Z is equal to X minus the mean over the standard deviation. So we're trying to find the Z score. We want the Z score, so we're going to fill in for X being 190 minus the mean of 177.6 that we found in part 1 over the standard deviation of 7.9. So our Z score for this particular data works out to be 1.56962, so on, which we will round to 1.57. So we are looking for the probability that a randomly selected adult male is taller than 190 centimeters. So the probability of x being greater than 190 would be equal to the probability of z being greater than 1.57. Now the probability of z being greater than 1.57 could be written also as 1 minus the probability of z being less than 1.57. So when we use our log tables book on our probabilities from enormous distribution, so page 37 here, we look at 1.5, so we want 1.57, and we get an answer of 0.9418. So we're going to do 1 minus 0.9418, and what we get is 0.0582. And that answer is worth 10 marks. For part B, a doctor working in a rural area of that particular country thinks that the mean height of adult males in that area differs from the national mean. She carried out a survey of 400 randomly selected adult males in the area and found the mean height was 176.5 centimeters and the standard deviation was 7.8 centimeters. So in this part, we're asked to carry out a hypothesis test at the 5% level of significance to see if the doctor is correct. State your null hypothesis and your alternate hypothesis, state your conclusion, and give a reason for your conclusion. So let's start by stating our null hypothesis. So we would state that the mean height of adult males in that area does not differ from the national mean, that being 177.6. The alternate hypothesis, which is the hypothesis of the doctor, is that the mean height of adult males in that area does differ from the national mean. And again, if you want to state it, that it's not equal to 177.6. So for our calculations here, we're going to use from page 35 in your log tables book, we are going to use the one sample z-test formula. And that is the formula z is equal to x bar, which is our sample mean, minus our population mean over our population standard deviation divided by the square root of n, our sample size. So we fill in the information we have. We have 176.5, which is the sample mean that we were given in the question, minus the population mean that we calculated before, all over standard deviation of 7.8 in this case, in the question, and our sample size was 400. When we work that out, we get minus 1.1 over 0.39, which works out as minus 2.82051281 into 2 decimal places, minus 2.82. So now to look at our conclusion. So at the 95% confidence interval, which represents our 5% level of significance, our Z value would be minus 1.96. Here we have minus 2.82, which is less than minus 1.96. So because of that, we reject the null hypothesis and accept the alternative hypothesis. My reasons for my conclusion are there is significant evidence to suggest the mean height is not 177.6 centimeters. Apologies again for the camera. That question in total was worth 10 marks. So the next part, we're asked to find the p-value of the test you performed in part B, part 1, and explain what this value represents in the context of the question. So in that part, we found that Z was equal to minus 2.82. So that was from part B, part 1. The probability of Z being less than minus 2.82 will be equal to 1 minus the probability of Z being less than positive 2.82. So we think about our our normal distribution. Here's our minus 2.82, our positive 2.82. So when we look on our Z tables, we can see that the probability, if we look on again page 37, I'm looking for 2.82, and I get 0.9976. So 1 minus 0.9976, which gives me 0.0024 as an answer. What we're looking at, the data on both sides here, is we're looking at twice that, which gives us an answer of 0.0048, which is 0.48%. Now that is less than a 0.05 or 5%. So what we would say there is we reject the null hypothesis. That's 5% level of significance. Now, an explanation, what we can say is that there is a 0.48% chance of finding a mean height of 176.5 centimeters if the null hypothesis is correct. That question was worth 5 marks. The last part of this question, part C, we're told that the doctor also carried out a survey of 400 randomly selected adult females in that area. She found that she found that the 95% confidence interval for the population mean height of females in the area was between 161.363 162.637 centimeters. We're asked to work out the mean, which is our X bar, mean height, and the standard deviation of the sample. So starting off with, we understand that the 95% confidence interval we know that the Z value is equal to 1.96. So to work out the 95% confidence interval for the population mean height of females in this area, what we would have to do is take our X bar minus 1.96 times by the standard deviation over the square root of n, and our X bar, our mean height, plus 1.96 times the standard deviation over root n. So when we fill in what we know, we'll fill in our population of 400, our sample size, sorry. From here also, 400. And we can look to simplify, we can get the square root of 400. So that ends up being 20. They're being multiplied. We'll just put a bracket around it. And the same here. And what we have in our question is we actually have an answer for each of those. So what we're going to do next is we're going to put what we have equal to the number that's given to us in the question. And the same for the second one. What we actually end up with here are pretty much we have simultaneous equations. And hopefully we can use to solve for our mean height and for our standard deviation. So what we notice is that these will cancel when we add our two equations together. So we end up with 2x bar is equal to, when I add these two together, it actually works out as 324. So x bar is equal to 162 centimeters. So that's my first answer. And if x bar is equal to that, then we can take any of our two equations we fill in. So for example, we have 162 minus 1.96 times the standard deviation over 20 is equal to 161.363. And we can use that to solve for the standard deviation. So we end up with 162. If I bring that over once, take away the 161.363, is equal to 1.96 times the standard deviation over 20. You could, if you wanted to, do a little bit of calculation work with that there at the same time. So we end up with 0.637 is equal to 0.098 times the standard deviation. So our standard deviation will be equal to 0.637 divided by 0.098. And we end up with an answer of 6.5 centimeters. And that question was worth 10 marks. Question 10. Luke's two favourite pastimes are darts and archery. When practicing for darts, Luke has a 2 out of 5 chance of hitting the bullseye on any single throw. In a particular practice session, he takes 5 throws. Find the probability that Luke hits the bullseye for the first time on his 4th throw. So if the probability of him hitting the bullseye is 2 over 5, then the probability of him not hitting the bullseye will be 3 over 5. So on his first throw will be 3 over 5, second throw 3 over 5, third the same, fourth throw 2 over 5. So when we do that calculation, we end up with 54 over 625, which you could write if you wanted to. You could leave it as a fraction. You could write it as 0.0864 as well. And that is worth 5 marks. The next part, we're asked to find the probability that Luke hits the bullseye exactly 3 times. So for this, we're going to use Bernoulli trial formula, or your binomial expansion formula, which is on page 33 in your log tables book. So he is taking 5 throws, so our n is 5, and we want the probability that he hits the bullseye, so of success on 3 of those occasions. And then we're going to take the probability of success to the power of 3 and the probability of not hitting, 3 over 5, so the probability of 2. And when we calculate this, we get 10 multiplied by 8 over 125 multiplied by 9 over 25, and that works out as 144 over 625. Could leave it as a fraction, or you can change it to a decimal, 0.2304, and that was worth 5 marks. So the next part, we're asked to find the probability that he hits the bullseye exactly 3 times on consecutive throws, so meaning one after the other. So the first possibility of that happening would be on the first, second, and third. So if we look at success on the first, second, and third throw, that means he would not hit it on the fourth and the fifth. The other possibility, okay, is we're going to add those together, because only one of these possibilities, or one of these situations will actually happen. So the first one, he misses, and then our consecutive throws are the second, third, and fourth, and then the fifth. He doesn't. And there's one other possibility, that he doesn't hit on the first, doesn't hit on the second, but then has success on the third, fourth, and fifth throw. So those are the 3 different ways that he could hit a bullseye exactly 3 times on consecutive throws. When we do our calculations, it's 72 over 3,125 for each of those brackets. So you can multiply by 3, or just show that we add them together. And there are 3 of them. When we add them together, we get 216 over 3,125. Again, fine to leave as a fraction, or you can change that to a decimal, 0.06912. And that was 5 marks. Okay, so find the probability that Luke hits the bullseye for the third time on his fifth throw. Well, if he hits it for the third time on his fifth throw, then in the first 4 throws, he has to be successful twice. So we're going to work on that probability first. And we can use our binomial expansion formula again, our Bernoulli trial, to help us with that. So if we look at 4 throws and 2 of those being successful, then we're having our 2 over 5 to the power of 2, or 3 over 5 to the power of 2. When we do that calculation, we get 216 over 625. So that's the probability of hitting the bullseye twice in the first 4 throws. We are asked to find the probability that Luke hits the bullseye for the third time on his fifth throw. Well, if we take the probability of him hitting twice in the first 4, again, it doesn't matter where those hits happen, and multiply it by success in the fifth throw, then we get our probability, our answer that we need. So we get 432 over 3,125. But again, you can change that to a decimal, 0.13824 if you want. And again, 5 marks. Then we're asked to find the probability that he hits the bullseye at least once. So if I'm looking at the probability of him hitting at least once, well, that means another way of thinking about that is 1 minus the probability of no bullseye, not hitting it at all. So that would be 1 minus, again, if I use my binomial expansion here, 5 throws, 0 successes. So we're looking at 2 over 5 to the power of 0, 3 over 5 to the power of 5. So that's going to be 1 minus 3/5 to the power of 5, which is 2,882 over 3,125. We'd leave it like that. Or it can also be written as a decimal of 0.92224. And that's worth 5 marks. Part B. When Luke visits the archery range, he shoots arrows at a circular target in which 1, 2, 3, or 5 points can be scored. The target is divided into 4 parts of unequal area by concentric circles as shown. The radii of the circles are 3 centimeters, 9 centimeters, 15 centimeters, and 30 centimeters. Assuming that a randomly shot arrow strikes the target in one of the 4 areas. So we are asked to show that the probability of scoring 5 points is 1 over 100. So the probability of scoring a 5 will be equal to, using the area here, so the 5 is the smallest circle, it has a radius of 3, so the area of the smaller circle is pi multiplied by 3 squared, out of the overall larger target, larger circle, which has a radius of 30 centimeters, so pi times 30 squared. That gives us 9 out of 900, which is where we get our 1 over 100 when we simplify. So that's our 5 marks for that question. We're asked to complete the table to show the probability of scoring 1, 2, 3, or 5 points with a single arrow. So the probability of 1 point will be pi times 30 squared. So the area of our full complete target minus the area pi times 9 squared, all over pi times 30 squared. And that's going to give me 675 over 900, which simplifies to 3 over 4. So the probability of scoring a 1 is 3 over 4. And we repeat that process for the others. So the probability of scoring a 2 is pi times 15 squared minus pi times 9 squared. So the area that we can score a 2 over pi times 30 squared. And we work that out and simplify it, and we get 4 over 25. And lastly, working out the area, possible area to score a 3 would be pi times 9 squared minus pi times 3 squared, again all over the total area. And we get 72 over 900, which is equal to 2 over 25 when simplified. And that question is worth 5. Given that an arrow does not score 5 points, find the probability that it scores 1 point. So for this particular question, we're going to use the general multiplication law. So that is the probability of A given B. And that is the probability of A intersection B over probability of B. So here we have a probability of 1, which I know is 3 over 4. The probability of not scoring a 5 will be 1 minus 1 over 100. So that is 99 over 100. So those are the two probabilities that we need to fill in here. So we're looking for the probability of scoring a 1 given that we're not scoring a 5. So the probability of those A intersection B, in this case A being the probability of scoring a 1, B being the probability of not scoring 5. So we're going to have 3 over 4 divided by 99 over 100. When we work that out, put that into our calculators, we get 25 over 33, which can be written as a fraction or as a decimal as well if you want, 0.75, 75, 75, so on. That question was worth 5 marks. Last question here. We're told that given that the total score of 6, a total score of 6 is obtained with 2 randomly shot arrows, find the probability that neither arrow scores 1 point. So we're looking here at the probability of not scoring 1 given a total of 6. So if you're not scoring 1 with a total of 6, well, your probability is going to have to be of scoring a 3 twice over the probability of scoring 6. So scoring a 3 twice will be 2 over 25 multiplied by 2 over 25 over, now the probability of scoring a 6 in total, okay, including the possibility of having a 1 in there as well. So you could score a 1, which is 3 over 4, multiplied by 5. Okay, so the probability of scoring a 1 and then a 5. Or you could score a 5 first, and then a 1. So 5 and 1. And the other option is the one that we have already talked about, which is a 3 followed by another 3. Okay, so those are all the possible ways of scoring a 6. So we would end up with 4 over 625 over 3 over 400 plus 3 over 400 plus 4 over 625. And that's just simplifying it down a little bit. So 4 over 625 divided by 107 over 5,000. Put that into our calculator, we will get 32 over 107 as our probability. Again, could be as a decimal as well, 0.299065 and so on. And that question was worth 10 marks.